So to find a copy of LineGraph, scroll right up to the top of our lab website and open this first area, the quick reference files. And right at the top of that is LineGraph. So open that up, and you want to enable the editing and enable content if you're on a Windows PC. If you're on a Mac, it'll look a little different, but you want to enable the macros. So once it's open, you should save this to your own personal files. So don't leave it open in your temporary folder, but actually go and save this somewhere. The reason why you want to save it is that it helps the macros, the computer code in the background, to run properly. So once it's open, LineGraph looks like this. And LineGraph is a program for graphing linear data. So we're going to put all of our data here in the X and Y areas of this table, and the program will automatically graph it for us, and it will automatically calculate the slope and its uncertainty, and our y-intercept and its uncertainty. So the program is going to do most of the work for us. So as I said, this is where the data goes. And down here at the bottom, you see that we're on something called the Data tab. And right beside it is the Graph tab. So let's click on that, and it takes us to the area where our data is going to get graphed by the program. So let's go back to the data table, and I'm going to type in some fake data. I'll also put in some uncertainties. And this is just a macro of Excel, which means I can use all the same tricks that you've already learned for working with Excel. So I can click and drag to copy this down, for example. I can also put in a formula. So equal sign, the value, star 0.02 to make it 2% of the value. Hit enter, it fills it in for me, and again, I can click and drag to copy my formulas down. Now you'll notice that as soon as I filled in all of my data, these gray boxes here filled in some data as well. So that's just the fractional uncertainties of your data, which will come in useful later for when you're trying to determine which of these two variables affected your experiment's precision the most. So there's also a space here to put in the title of the graph, the x-axis label, the y-axis label, and your name. So I'm going to pretend that this data is for the simple pendulum experiment. So my x-axis label would be the length of the pendulum. And my y-axis label would be the period squared. So period squared. And then I want my symbol. And LineGraph doesn't do a very good job of superscripts and subscripts. So I'm going to just type in capital T, the caret symbol, and 2 for t squared. And for the units, same thing. It would be s caret symbol 2 for seconds squared. So then I'll put in my title. And I will accept it if you just describe the experiment. So for example, the simple pendulum. I'll also accept it if you try to describe what you're trying to get from your graph. So another valid title would be determining the acceleration due to gravity. So both of those would be acceptable titles. So now, if I click on my Graph tab again, all my data is graphed for me, and it's filled in the title and the labels on the axes. So it puts in everything for you except for the equation of best fit. You will need to add that. So it does put in these little equations here, but I don't consider those valid because they don't have uncertainties and they don't have units. So you do need to put in a proper equation of best fit on your graph before you save it and submit it to your lab instructor. But before we put in our equation of best fit, let's go back to the data table for just a second. I want to draw your attention to this second table, table 2. Table 2 is where the program tells you what your slope is and its uncertainty, and what your y-intercept is and its uncertainty. So it calculates these values for you, and that's the information you need to write your equation of best fit. So I'm going to go back to the graph now and put on my equation of best fit. Now I'll warn you that inserting an equation into Excel on a graph is not quite as easy as inserting an equation into a Word document. It's similar, but there's one thing you need to do before you start typing in your equation. So if we were in Word, to insert an equation, all I'd need to do is click the Insert tab and then click Equation. But here, that equation option is grayed out. So we need to do something else first, and that is that we need to insert a text box. So to do that, go to this Insert tab, and then you want to go here under Shapes and insert a text box, which is up here in the corner. So I click on that, and then I can click and drag to draw a text box on the graph. And so I could start typing in whatever I want here, but rather than typing in just text, which you can do, I'm going to insert a properly typeset equation. And at this point, inside the text box, I can do that exactly the same way I would in Word, where I'd click Insert, Equation, and then it inserts this equation area for me, and I can use the menus up here on the Design tab under Equation Tools to type in a properly typeset equation. Now, before I show you that, I'm actually going to increase the size of the font just so that it's easier for you to see. And then I'll go back to my Design tab. So if you haven't learned how to insert an equation into Word yet, don't worry, you're going to learn that soon. But to give you a quick version of it, you're going to use these tools up here on the menu bar on the Design tab to fill in whatever symbols you need. So my equation is going to be, for a pendulum, t² equals my slope value times L, my x-axis variable, plus the y-intercept. So to begin with, I want that t². So to get a superscript, I'd go up here to this script option on the Design tab, and it's got superscripts and subscripts. So I'll select the superscript, and now you see that inside my equation I've got this box raised to the power of other box. So I click into the big one, type a t, I can use the side arrow to get into the small one, type a 2, and now I've got t². Side arrow again on my keyboard takes me out of the superscript, and then I can keep typing. So I'll put in my equal sign. Next, I would want to put in my slope value with its uncertainty and units. So I'll get to that, but for now I'm just going to put in a set of brackets as a placeholder. And I do use the brackets up here on the Design tab just because they will automatically resize if I add something tall to my expression, like a fraction. So my x-axis variable would be L for length of the pendulum, and then plus sign, and next I would put in my y-intercept, again with its uncertainty and its units. So I'll stick in a pair of brackets again as a placeholder for those. So now I want to actually fill in my values. Let's go back to the Data tab to find out what those are. So I'll go back to the Data tab, look in Table 2, and it tells me that my slope value is 5, and its uncertainty is this 0.38095, whatever. So I need to round off my uncertainty, so that would get rounded to 0.4, and then I need to pad the end of my slope value with a 0 so that it has the same number of decimal places as the uncertainty. So my value for my slope would be 5.0 plus or minus 0.4. So now let's go back to the Graph tab and add that. So here my value is going to be 5.0, and I need a plus or minus symbol here. Where do I get those from? Well, this menu up here has them. To expand it, you click this little icon here, and that expands it, and then I can go looking around for the plus minus symbol, which is right there. So I add that, and then I type in my uncertainty, 0.4, and now I need units. So the units on this graph for the slope would be rise over run, so that's seconds squared per meter. So that's what I need to put in here. And again, on the Design tab, you've got a little icon here for fractions. So I click the down arrow, and there's a big fraction and there's a little fraction. So I'll use the little fraction for my units. Go into the top of this, it'll be seconds squared on the top, so I need a superscript. Fill that in. Down arrow to get to the bottom, and this would be meters, so M. And there's my units for my slope. And over here, we're going to fill in the y-intercept in the same way. So I go back to my Data tab, look at Table 2, and it says that my y-intercept is 0, and its uncertainty is 0.9 once I round it off. So that means I'll pad the end of my y-intercept value as well to be 0.0 plus or minus 0.9. And so now I go back to my Graph tab, and I fill that in. 0.0, little down arrow here to expand this, plus or minus 0.9, and the units on my y-intercept would be the same as the units on my y-axis, which are seconds squared. So again, choose this, choose a superscript, and type in seconds, side arrow, 2 for seconds squared. And there's my completed equation of best fit. So that's how you add an equation of best fit. Just to recap, you'd click on Insert and choose a text box under Shapes, and then you'd click and draw in a text box, and then you can go Insert Equation to add an equation into it and fill it in. So at this point, you can then save this file and hand it in to your lab instructor by electronically submitting this document to them. So now that I've shown you how to do this, I'm actually going to show you 2 more tricks having to do with LineGraph. So going back to our data table again, I typed in all my values, but sometimes you don't want to type in your values. You actually want to get them from an Excel spreadsheet that you've already filled in. So I'm going to show you how to do that now. So first, let me get rid of my fake data. And then I'm going to go into a spreadsheet that I already had open with a bunch of real data in it. So the idea here is that I've already filled in my spreadsheet. I just opened up LineGraph, and I want to now copy the data that I already worked out here on my spreadsheet into LineGraph. So you could just click your data and copy it, and then go into LineGraph and paste it. But there's a better way. Instead of clicking paste, click the down arrow underneath it and go down here to paste link. And I'm going to explain why that's better in just a moment. But let's repeat that to get our other set of data. So I go back to my spreadsheet, highlight the data I want to copy it, go back to LineGraph, click where I want that data to appear, and again, click the down arrow and click paste link. And it fills it in for me. So the reason why this is better is if you've got a problem in your spreadsheet that you want to fix. So let's go look at the graph. And you'll notice that there's a problem with the data in that there's this one data point that's way off the line. So whenever you see that, you should figure out what's going on with those data points. Double check that you haven't miscalculated something or typed it into your spreadsheet wrong, and if necessary, you'd remeasure that one item of data to see if you can get better agreement. So I've got one data point here that I know doesn't look right. So I'd go back to my spreadsheet, and I'd hunt around for the error, and if I find it, so say I realize that this data point here was typed in wrong, and fix it, now my spreadsheet's fixed, and if I go back to LineGraph, it automatically fixes itself also. So that's why it's better to do this copy-paste link into LineGraph with your data, because if you need to change the spreadsheet, LineGraph will automatically fix itself. So that's the first trick I wanted to show you. I have a second one as well. So going back to the Data tab, let's just say that this is not my data, that this is my data instead. So let's have a look at it on the graph. And here we see that the data looks okay, but it's all squished into a little band at the top of my graph, just because my data started at 30 rather than at 0. So the axis by default starts at 0, and depending on your data, that's not necessarily nice looking. So we can fix this. So what you do is you click the numbers. That highlights the entire row of numbers on this axis. Then you right-click, and you click on Format Axis. And that will allow you to then change what the minimum number on your graph is. So I'll change this to 28, for example. Click back on my graph, and I can get rid of this. And now you can see it has stretched things out. And if I wanted to, I could do it on this other axis as well. So click on a number, it highlights the entire axis of numbers, then right-click, Format Axis, and just change what the minimum value is. So I'll change this one to 2. And again, it adjusts the axes so that now my data fills the page. And again, when you're happy with how your graph looks, including putting your equation of best fit on, you can save this file and then hand it into your lab instructor electronically.